Hey guys, here's some help for you on the Alien project, tour guide project. If you are struggling with how to write the linear equation from your 2 points, so for example, I have just a small sample of a graph where I picked 2 locations. I don't know that these are historical locations at all. I didn't even name them, okay? I just picked them. So I want a slope-intercept equation for this. Well, I could count the slope easy enough by counting my rise and my run here. But you see where it's going to be very hard to tell where the y-intercept of this line is. It's going to keep increasing pretty high, and I'd rather not stack graph papers up to see where it's going to cross. So the easier way to do it is mathematically. So I have my 2 coordinates here, negative 15, 8, and negative 19, negative 2. You can see my 2 points. So I don't know, maybe I went from Salina to the first to the pink dot, and now I'm going to the blue one. So you're going to have 2 sets of coordinates. Here I've got negative 15, 8, and I have negative 19, negative 2. You want to be really careful to write those coordinates correctly, or else all your math is going to get messed up. Now, to find the slope, the first thing I'm going to have to do is find the slope. So I'm going to take y2, which in this case would be negative 2, minus y1, according to my formula. So 8 over x2 minus x1. And so anytime you have minus and a negative in a problem, you're looking at that actually becomes addition. So negative 2 minus 8, if I think about being on a number line, is negative 10 over negative 19 plus 15 is negative 4. And then if I simplify that down, the 2 negatives cancel each other out. I can divide them both by 2 to get 5 halves. So my slope in this situation is 5 halves. Is that a reasonable slope? Okay, we always want to think reasonable on this. Yeah, because if I actually think about from this dot to this dot, I'm going up 5, 1, 2, 3, 4, 5, and over 2. Up 1, 2, 3, 4, 5, and over 2. That's a pretty good match. It's a positive because my line is rising. So it doesn't matter even if I'm traveling from the pink dot to the blue dot. You kind of have to back up and just say, okay, is that a positive line or a negative line? It's a positive line. Okay, so that is my slope value. I'm going to need that information. Now, my instructions say to use point slope form. So I'm going to use this formula, and I'm going to write y minus the y1 value. So my y1 value, oh, I used the wrong color. I'm sorry, that should be pink. My y1 value is actually this 8 right here, equals my slope, which is the 5 halves, times x minus the x1 value, the negative 15. And again, we have this situation where when you subtract a number that's a negative, it becomes addition. Okay, so I have now filled in y1, the slope, and x1, okay? Then it says convert to the slope-intercept form because we want this version. This is our favorite version, okay? So I'm going to distribute first. I'm going to distribute that 5 halves. The y minus 8 isn't changing. I get 5 halves x plus, this is where you might use, oh, sorry about the bell. You might use a calculator, convert this to a decimal, whatever you need to do to figure out that 5 halves times 15 is actually 37.5. Okay, so there we go. Now, the next thing I need to do is isolate the y value. So I'm going to add 8 to both sides, and I get y equals 5 halves x plus 45.5. Okay, that is my actual equation between these 2 dots. Now, I want you to always consider, is that a reasonable formula? Well, if I go back to my graph, we already said the slope of 5 halves is reasonable. Okay, it goes up 5 over 2, rises 5, runs 2. The 45.5, it's reasonable, okay? It's reasonable that this thing is going to hit somewhere up in the 40s. An unreasonable answer would be if for some reason I worked out something that was a negative. A negative y-intercept is clearly not where this line is headed, okay? Even anything like, I don't know, 0 to 15 or so is pretty unreasonable to say that line is going to cross the y-axis over here. That's not logical, okay? So I hope that helps you guys.